Good evening, everyone. In the last class, we discussed about the vector addition of the two vectors, and we also discussed some of the properties of vector addition, where we discussed about the commutative property as well as associativity of the vectors, and we found that the vector addition is commutative as well as associative in nature. And we also solved many examples related to the range of the vector addition. If we have two vectors A and B, the minimum value of the two vectors, minimum value of the resultant of two vectors A and B will be A minus B, mod of A minus B, and the maximum value will be modulus of A plus B. So the resultant of the two vectors will always lie between A minus B and A plus B. So the magnitude of resultant of two vectors is always going to lie between A minus B and A plus B. So A plus B is the maximum value and A minus B is the minimum value. The range of the vector magnitude of the resultant vector is between greater or equal to modulus of A minus B less or equal to modulus of A plus B. So with the help of the range of vector addition of two vectors, we could predict that if there is some third vector C, whether that third vector C can give a resultant equal to 0 for all the three vectors or not. It's only possible if the range of that third vector C only lies between the range of the resultant of the two vectors A plus B and A minus B. That's the minimum value of R and the maximum value of R. Otherwise, the resultant of the three vectors cannot be 0. There will be always some magnitude of the resultant of all the three vectors. So this is how we can check whether the three vectors will be giving 0 resultant of all the three vectors. So let's try to solve some of few questions related to vector addition. Here we have a simple problem of the vector addition of two vectors. The two forces, each of magnitude f, have a resultant of the same magnitude f. The angle between the two forces is. We have two forces. Suppose that this is vector f, it is in this direction, and there is one more vector. Let me call this f1 and this vector is f2. And the angle between these two vectors is theta. It's given that the magnitude of both these vectors f1 is equal to f2, means modulus of f1 will be equal to modulus of f2. And it's also given that the resultant of these two vectors also comes out to be equal to f1 and f2. The magnitude of the resultant also comes out to be equal to magnitude of each of these two vectors f1 and f2. We have to find the angle theta. What should be the angle theta so that this is possible that resultant as well as the two vectors are having the same magnitude. We know that whenever we have two vectors which are at an angle of theta, we derive this relation that if we have two vectors of same magnitude at an angle of theta, so the resultant is nothing, it's given by twice the magnitude of one of the vector, that's 2a cos of theta upon 2. And this we have done in the previous class. If we have two vectors and both the two vectors are having same magnitude, but they are inclined with each other at an angle of theta, then the resultant is equal to twice a cos theta by 2, where a is the magnitude of one of the vectors. So we can directly use this result here. Suppose r is the resultant of these two vectors and the magnitude of each of these forces is f. So it will be 2f cos of theta upon 2. And it is also given that the resultant magnitude of the resultant is also equal to the magnitude here f. So we can replace r with f here. So it will be getting 2f cos theta upon 2. F and f will cancel out. So from here we get cos of theta upon 2. That is nothing. It's equal to 1 upon 2. And we know that the value of cos of theta is 1 by 2 at an angle of 60 degree. At an angle of 60 degrees. So we can replace this 1 by 2 with cos of 60. So from here we can get that theta upon 2 is nothing. It's equal to 60 degree. So it means that the angle theta is nothing. It's 2i60. That is 120 degree. Means that these two forces F1 and F2 must be inclined at an angle of 120 degree with each other. So this is how these two forces will be inclined with each other. So the angle between these two forces will be equal to 120 degree. 120 degree. And the resultant will bisect this angle 120 degree. So this resultant will make 60 degree angle with one of the vectors or both vectors here. They will bisect the angle 120 degree. So this is our resultant, and the magnitude of this resultant is same, that's equal to mod of f1 mod of f2. So 120 degree is the answer for this question. Let's move on to another problem, very simple and basic. The maximum and minimum resultants of two forces are in the ratio 7:3. The ratio of the forces is, we are given two forces. Let's suppose that the two forces are F1 and F2. These are the two forces, F1 and F2. And let's suppose that these two forces are inclined at an angle of theta. These two forces are inclined at an angle of theta. So the maximum value we can get for the resultant of these two forces is nothing, F1 plus F2. And the minimum value we can get is that if the two forces are along the same direction, then the maximum value will be F1 plus F2. And if these two forces are anti-parallel to each other, so we'll be getting the resultant as F1 minus F2. So this is the minimum value. So this is maximum R max. So this is R minimum. It's given that the ratio of R max and R minimum is 7:3. We have to calculate the ratio of these two forces. So it's nothing, F1 plus F2 upon F1 minus F2. That's given as 7/3. We can just cross multiply this. So we get 3F1 plus 3F2. That's equal to 7 times F1 minus 7F2. So we'll be getting here 3F2 plus 7F2. Taking F1 in the RHS, so it will be 7 times F1 minus 3 times F1. So it's nothing, 4 times F1. So here we get 10 times F2. That's equal to 4 times F1. So from here, F1 upon F2 is nothing. That's equal to 4 upon F1 upon F2. That's equal to 10 upon 4. 10 upon 4. So it will be 10 upon 4. That's nothing. We can write it as 5 upon 2. The ratio of F1 and F2 is 5 upon 2 or 5:2. So this is the ratio of the two vectors F1 and F2. So that was it with respect to the vector addition of two vectors, and all the properties of the vector addition has been done. And we have also solved some of the questions related to vector addition in the previous class also and today also. Let's suppose that if we have more than two vectors, If in a space we have more than two vectors, then how can we find the resultant of more than two vectors? To find the resultant of more than two vectors, like we can have three vectors, four vectors, or five vectors in a space. If we want to find the resultant of all those vectors in a space, we need to use Polygon law of vectors. So Polygon law of vectors will help us to find the resultant as well as the direction of that resultant also. It will not only help us to find the magnitude, but also the direction of that result. So the Polygon law of vectors is that, suppose that we have some vectors like here, vector A and its vector B, and this is vector C here. We can have n number of vectors. Let's suppose we are taking three vectors, A, B, and C. But all these vectors A, B, and C are taken in the same order. Taken in the same order means that the tip of the vector A must lie on the must lie on the tail of the vector B, and similarly the tip of the vector B should lie on the tail of the vector C. So A, B, C are the three vectors which are taken in the same order. Suppose that if A, B, C are the three vectors and these three vectors represent the sides of a polygon. A, B, C are the three vectors, they represent the sides of the polygon. Let me write it here. A, B, and C are the three vectors which form sides of a polygon, but taken in the same order. But taken in the same order. So if A, B, and C are the three vectors which are taken in the same order, this is A, this is B, and this is C vector. They are taken in the same order. And these three vectors represent the sides of a polygon. Then the vector which closes this polygon. Then the vector which closes this polygon, but that vector is taken in the reverse order. Suppose that this is the vector D. Now this vector D closes the polygon, but this vector D has been taken in the reverse order. Means now this vector has been taken from tip to tail in the reverse order. Now this vector D encloses this polygon, closes this polygon, and this D vector represents the resultant of these three vectors. So this vector which is taken in the reverse order and completes this polygon is nothing, it's the resultant of these three vectors. So we can write that D vector is nothing, it's A vector plus B vector plus C vector. So this is nothing, this is what we call as polygon law of vectors. Polygon law of vectors. So this is polygon law of vectors, that if some of the vectors represents the sides of a regular polygon and they are taken in the same order, they are taken in the same order, then the vector which completes the polygon but taken in the reverse order is the resultant of all those vectors. Let's suppose that this is a regular polygon. This is a polygon, or you can say this is a hexagon here. This is a hexagon here. Let me call this hexagon as A, B, C, D, E, and F. So AB is a vector here, and BC is also a vector, and CD is also a vector, and T is also a vector, and all these vectors are taken in the same order. But suppose that FA, FA is taken in the reverse order. FA is taken in the reverse order. AB vector, BC vector, CD, and DE, all these four vectors, 1, 2, 3, 4, 5 vectors are taken in the same order. But this FA vector, which is taken in the reverse order from tip to tail, this represents the resultant of all these five vectors. The resultant of all these five vectors. So we can say that this AF vector is nothing. It's the resultant of all these vectors. We can write as AF vector is equal to AB vector plus BC vector plus CD vector, DE and EF. DE and EF. So this is basically the polygon law of vectors. If we have multiple vectors which are taken in the same order and represents the sides of a polygon, then the vector taken in the reverse order which completes the polygon is a resultant of all those vectors. So let's suppose that we have a regular polygon. We have a polygon here, regular polygon here. This is a pentagon here, A, B, C, D, and E. Now these vectors, AB vector, BC vector, and all these vectors are now taken in the same order. All vectors forming pentagon here, forming pentagon, are taken in same order. In same order. All vectors forming pentagon are taken in same order. If all these five vectors are taken in the same order, the resultant of all the five vectors will be zero always. So resultant will be zero always. The reason being that if we add all these vectors will be cancelling out each other. One vector will be cancelling out the another vector. So at the end, what we get is that the sum of all these vectors comes out to be zero, provided all these vectors are taken in the same order and forming a regular and are forming a regular polygon. So even if the hexagon is formed, but all the six vectors of a hexagon are taken in the same order, the resultant of all those vectors is going to be zero. The resultant of all those vectors is going to be zero. So even if we take a hexagon here and we're taking all these vectors in the same order, so the resultant is once again going to be zero. So resultant will be zero. So in your exams, only up to addition of the two vectors will be asked, but you must know little bit information about polygon law of vectors also. If more than two vectors are there, then how we can add the three vectors, four vectors, or five vectors using the polygon law of vectors. But rest in your exams only up to uh, triangle law of addition or the parallelogram law of addition, where we add two vectors only, will be asked. Let's move on to the next topic, that's our vector subtraction. It's as as important as the vector addition. Let's suppose that we have two vectors in the space So we are supposing that we have two vectors A and B. We have two vectors A and B. This is A vector and B vector. Then the vector subtraction of these two vectors, then the vector subtraction of these two vectors, this is A vector here and this is a B vector here. Suppose that these two vectors are inclined at an angle of theta. The vector subtraction will be represented by A minus B. A minus B. It means that we can also write this vector subtraction A minus B as A plus minus B. Here minus B is nothing, it's the negative of the B vector. Negative of B vector. It means that we can get minus B only if we reverse the direction of B vector, we'll be getting the minus B vector. Suppose in this case, if we reverse the B vector here, this is our B vector, and then this will be our minus B vector. And if the angle between A and B is theta, and this complete angle here on the line is 180 degree, so this angle is nothing, it's 180 minus theta. This angle is 180 minus theta. So vector subtraction here is nothing, it's just the same as that of vector addition, but what we are doing is that we are just adding the vector A with the negative of vector B. We just add here the vector A with the negative of vector B. So the resultant of these two vectors will be here in between A vector and minus B vector. So this will be the resultant, or this vector is going to be A vector minus B vector. So it's just like we're adding A vector and minus B vector, and A vector minus B vector is the resultant of the two, and the angle between them is now 180 minus theta. So angle between A and B was theta, but the angle between A and minus B is 180 minus theta. So we'll be using the same equation, that A vector plus B vector is nothing, it's equal to mod of A vector plus B vector. It's under root of A square plus B square plus 2AB cos of theta. Under root of A square plus B square plus 2AB cos theta. But here what we are doing is that we are adding the A vector and negative B vector and finding the modulus of this vector. So it will be A square minus B square will be B square again, and it will be twice AB cos of 180 minus theta, because now the angle between A vector and minus B vector is 180 minus theta. So theta will be replaced by 180 minus theta. So cos of pi minus theta is nothing. Cos of pi minus theta is minus cos theta. So it will be A square plus B square minus 2AB cos of theta. Minus 2AB cos of theta. So the magnitude of A minus B is nothing. The mod of A minus B is nothing. That's equal to under root of A square plus B square minus twice AB cos of theta. Now suppose that this resultant of A and B vector, A and minus B vector, they are making an angle of alpha here with A vector. Angle of alpha here with A vector. So how can we find this angle alpha? We know that tan of alpha for A plus B was equal to B sine of theta upon A plus B cos theta. But here in this case, our theta is nothing, it's equal to pi minus theta. It's pi minus theta. So our tan of alpha is nothing p sine of pi minus theta. Pi is in radians. In degrees, the pi is equal to 180 degree. So we can place here a plus b cos of pi minus theta. Sine of pi minus theta, it's going to be same that sine of theta, and cos of pi minus theta, that's equal to minus cos of theta. So we can just substitute the value of these angles here in this equation. We'll be getting tan of alpha, it's nothing, it's p sine theta upon a minus b cos theta. So our angle alpha is nothing, it's tan inverse of p sine theta upon a minus b cos theta. So this is the angle which a minus b vector makes with the vector a, tan inverse b sine theta upon a minus b cos theta. And the magnitude of a vector minus b vector is given by this equation, that is under root of a square plus b square minus 2ab cos of theta. Let's suppose that if we have two vectors, such that two vectors a and b, a and b are the two vectors at an angle of theta, at an angle of theta, such that mod of a is equal to mod of b vector. Mod of a vector is equal to mod of b vector. Then the mod of a minus b we have to find. Mod of a minus b. So mod of a minus b is nothing. It's under root of a square plus b square minus 2ab cos theta. But the magnitude of a and b is same. We can replace b with a. So we'll be getting a square plus a square minus twice a square cos of theta. So 2a square will be common here. 2a square will be common here. It will be left with 1 minus cos of theta. So we know one of the important trigonometric identity, that cos of 2 theta, that's equal to 2 sine square theta plus 1. 2 sine square theta plus 1. So from here, cos of theta we can write as 2 sine square theta upon 2 plus 1. From here we can replace sine 1 minus cos theta will be equal to, so cos 2 theta is 2 sine square theta. Okay, just a minute. So it is 1 minus 2 sine square theta. So cos theta will be 1 minus 2 sine square theta upon 2. So from here 1 minus cos of theta will be equal to 2 sine square theta upon 2. So we can replace 1 minus cos theta in this equation with 2 sine square theta upon 2. This is our 2a square. So we can replace it with 2 sine square theta upon 2. So it's nothing. 2 and 2 multiplied by 2 is 4a square. So under root of this will be 2a, and square and root of sine square theta will get cancelled. We'll be left with sine theta upon 2. So the resultant we are getting of modulus of a minus b, it's nothing. It's 2 times a sine theta upon 2. Or we can also write it as 2 times b sine theta upon 2. 2 times b sine theta upon 2. It means that if we have two vectors a and b of equal magnitude having the angle between them as theta, then the result magnitude of the resultant of a minus b will be always given by 2a sine theta by 2 or 2b sine theta by 2. And the resultant will always bisect the angle between a vector and minus b vector. So this is how the resultant will be. This is a vector and this is our b vector. And this is our minus b vector. This is our minus b vector. Then this will be the resultant of a minus b. So it will be bisecting this angle. In the same manner, if we have two vectors of equal magnitude at an angle of theta, then the mod of a plus b is twice a cos theta upon 2. So both these results will be used when we will be studying the kinematics and where we will be studying about the change in velocity, particularly in a circular motion. We will be using these two results directly there. We will not be deriving any such result or any such thing, or we can also find these two results directly from the vector resolution also, but that will be done later on in this chapter. But till now I have analytically solved how the magnitude of the a minus b is found if the magnitude of a vector and the b vector are equal. So let's try to solve a simple problem here, that angle between two vectors a and b having magnitude 5 Newton and 10 Newton is 37 degree. Then find out a minus b, mod of a minus b. It means that we have two vectors here, 5 Newton and another vector here as 10 Newton. Angle between them is 37 degree. Angle between them is 37 degree. You know, suppose we have this triangle here and this angle is here 37. This angle is here 37. If this is 4, this is 3, then this side hypotenuse here will be 5. So sine of 37 degree, if we try to calculate, or the cos of 37 degree from here in this triangle, cos of 37 degree, so cos of 37 degree will be 3 upon 5. 3 upon 5. So we can directly use the equation of a minus b, that's under root of a square plus b square minus 2ab cos of 37. The value of a is given as 5, so it will be 5 square, and b is 10, it will be 10 square minus 2 5 into 10 cos 37, that comes out to be 3 upon 5. This 5 and 5 will get cancelled, so it will be 125 minus 60 minus 60, so it will be under root of 65. Under root of 65, it will be approximately close to 8 but slightly greater than 8. It can be approximately equal to 8.1. So this will be the magnitude of a minus b. The vector subtraction is also used in mechanics also to find different physical quantities, like we find change in momentum. In finding the change in momentum, we also use vector subtraction. In finding the change in velocity, we use this vector subtraction. And also in the change in position, that will be defining later, that change in position vector gives us the displacement vector, right? So these are some of the applications of the vector subtraction. And we also here have a simple uh, case here, that suppose that there is an insect in this figure which is moving in the horizontal direction along the positive x-axis. And if the initial velocity of this insect is given as 5 meter per second and the final velocity is given towards the north, suppose that this insect is initially moving towards the east and this insect is here is moving towards the north. So this is the final velocity, that's 5 meter per second but towards the north. And here we have 5 meter per second, that's towards the east. So change in velocity will be nothing, it will be final velocity minus initial velocity. So it will be nothing under root of vi square plus v final square minus twice v initial v final cos of theta. We can see that both these velocities are inclined at an angle of 90 degree here. So cos of 90 is nothing, it is 0. The magnitude of change in velocity will be under root of 5 square plus 5 square, that is root 50 or 5 root 2 meter per second. So this is the change in velocity in this case. So let's stop here. In the next class, we'll be discussing more about the vector subtraction and we'll be discussing some of the properties of the vector subtraction as well. And we'll be also solving some of the good problems on vector subtraction. Okay, till then, take care and goodbye.